Well, welcome to 1-3. We're going to be discussing what is a function and some various aspects. So the definition of a function is from set A to set B, a relation that assigns each element x in the set A exactly one element y in the set B. The set A is a domain or set of inputs, the function of the function f, and the set B contains the range or set of outputs. A function is any time that you have something as a function of something else. So I put an input value and that input results in a certain output. You can think of a real life application. The more water I put inside a container, the more the volume is filled up. That's a function. Testing for functions, determine whether the relation represents y as a function of x. So the input value x is the number of representatives from the state. The output y is the number of senators. Okay, you have a function here. Because your input value, you have the number of actually this would not be a function. My apologies. The input value x, the number of representatives. The y value is the number of senators. You have to think of, in a function, something is independent, something is dependent. Both of these are either dependent or independent variables. You know, if you're talking about, like, the United States Congress, the example here, well, the representatives for a state is based on the population. So the representatives is a dependent variable, and it depends on the population of the state. So, for example, California has a lot more representatives than Rhode Island. Rhode Island is, I don't know, probably not even the size of Houston, whereas the number of senators is independent just simply because the Constitution says there are two. The main way to test for functions is you look to see, do I have two, there are two tests that I do. One of them is called, you just basically check the x values, and then the other one is called a straight line test. So notice here how in B I have two x inputs that are both 2. As a result, this is not a function, because a function will not repeat the dependent. I have two dependent inputs. A function will not repeat it. Whereas a function will have, it would not have 211, 210. It may have 2.511, 210, but it will not have two of the same. Now over on the right we get the opportunity to do what's called the straight line test. And that is, if I have a graph, here's my parabola, I can do a straight line. They also call it the pencil test. But the idea being that I can lay a straight line that goes vertical anywhere on this graph, and it will touch the graph only once. So notice it does not intersect that red graph only but once at any given point. That makes it satisfy the vertical line test. That means you don't have a repeat of x values. Thus, it is a function. You can also test them algebraically. So which of these equations represents y as a function of x? Y as a function of x. Well, if I were to subtract x squared from both sides, I'd have that y equals negative x squared plus 1. There is nowhere here that I'm going to have a repeat of this. If I graph this, this graph is going to have a y-intercept of positive 1, and it's going to go down like so. So you will never have a repeat of x values. Whereas over here on the right, what you actually have with a y squared is you actually end up having y squared minus 1 equals x. So what you end up having is a parabola that will look like this. Because when I plug in an x value of 0 and I solve for y, I'll get y will either be positive 1 or negative 1. If I plug in a value of 3 for x, y will either be positive 2 or negative 2. It also fails, I'll draw it in a different color, it also fails the straight line test. Because if I graph it and I take a vertical line through it, it's hitting the graph here and here. Now, when we say evaluate a function, this is something you're very familiar with. They teach you this. It's the substitution property of equality, and it is simply the plug it in property. You are given a function. Now they will tell you if g of x is negative x squared plus 4x plus 1, now find each of these. So what is g of 2, g of t, and g of x plus 2? Well, for g of 2 will simply be negative 2 squared. Now, key here that I leave that negative outside and I'm not squaring the negative, plus 4 times 2 plus 1. So I get negative 4 plus 8 plus 1. So negative 4 plus 8 is 4, plus 1 is 5. Now I can plug in another variable, g of t. So if I plug in g of t, what I'm doing is I'm substituting now a letter variable. So I'll have negative t squared plus 4t plus 1. That's as far as that one will go. I can't do any more on that. It doesn't simplify any further. The next one, I am plugging a binomial expression, which binomial means two parts, so x plus 2. I'm plugging that into the equation. So I'll have g of x plus 2 is equal to negative x plus 2 squared plus 4 times x plus 2 plus 1. So now I have to treat this operation for here like I'm foiling it. I'm going to bring this, I'll zoom in so that you can see it better. So I'll have negative x plus 2 times x plus 2 plus 4 times x plus 2 plus 1. Remember, for foiling, I do my first, my outer, my inner, and my last. So I'll have negative x squared plus 2x plus 2x plus 4. Then I'm going to go ahead and take my 4 and distribute it through. 4 times x is 4x. 4 times 2 is 8. Then I'm left with a plus 1. These two can combine like terms to be 9. And I'm going to distribute my negative through. Those two become plus 4x, so now they're minus 4x, minus 4, plus 4x, plus 9. Okay? Combine like terms, those two and those two. So I'll have negative x squared. Minus 4x and plus 4x cancel out. And negative 4 plus 9 is positive 5. So if I evaluate the function of x squared plus 4x plus 1, where the x value I substitute in x plus 2, my resulting answer, g of x plus 2, is negative x squared plus 5. Now, a piecewise function is a little bit different. A piecewise function, the definition is in the name, and that is you have pieces. So what a piecewise function is that you will have a function that is comprised of different functions. So, for example, x squared plus 1. So if I were to graph this, here's what this looks like. I go to positive 1 on the x-axis. Now, where x is less than 0, where x is less than but not equal to 0, then it's going to go this graph. So I have a hole in it, and it goes like so. And then where x is greater than or equal to 0, at x minus 1, so negative 1 on the x-axis, this time with the solid dot, it goes like so. So what you have here are two pieces that create a function. These two pieces create this function. Notice I have a hole right here, but down here this is solid. This was determined by my symbols or my signs of whether or not they had an equal sign. So now I want to evaluate it when x equals negative 1, 0, and 1. Well, when x equals negative 1, it's going to go with the first function. Why? Because when x is less than 0, it follows the pattern of x squared plus 1. So I'm going to take the negative 1 squared plus 1. We're doing f of negative 1. And that will equal 2. Negative 1 squared is 1. Plus 1 is 2. At f of 0, I will now be in the second function, because where x is greater than or equal to 0, it follows x minus 1. 0 minus 1 is negative 1. And for positive 1, because it is greater than 0, f of 1 will equal 1 minus 1, which will be 0. So a piecewise function, it's like you're putting two graphs on the page, but then you erase parts of the graphs based on the domain restriction. Remember, domain is your independent variable, which means it's your x value. What you would typically call your x value, that's what we would call your independent, which is your domain. So if your domain is restricted, and those right there are your restrictions, we'll call those domain restrictions, they determine where we graph what we graph on there and where it does not extend to. Think of it as a relay race in track. One graph gets you to one point, another graph takes it the next way. Okay? Now, determining whether or not a function is odd or even. A function is even if I substitute in basically a negative 1 in the equation, or put it in actually a negative x, and when I solve it out, it equals the original equation. And it's odd if I plug it in and it ends up giving me the negation of the function. Let me demonstrate. The function x cubed minus x is odd because when g of negative x is plugged in, negative g of x is the resultant as follows. So if I have this, I'm going to have g of negative x is going to equal negative x cubed minus negative x. Now when I cube a negative, the negative remains. And then I have negative times a negative is a positive. So g of negative x equals negative x cubed plus x. When I compare, when I compare this function to this one, notice the signs are flipped. That's because of the powers within the function. When you plug in the negative sign within it and you solve it out properly, the function causes it to get changed to negative because of the powers. Because I have a cubed function, so I plug in negative in there, the negative is not eliminated or filtered out by the cubed. And the second variable is the first power, x to the first power. If I plug in a negative there, that's not filtered out either. Come on. But in the second one, the function h of x equals x squared plus 1 is even because h of negative x equals h of x as follows. So if I take h of negative x, I will take negative x, square it, plus 1. When I square a negative, it is eliminated. So h of negative x results in the original equation with no sign being flipped around or made funny. So as a result of that, because those two are the same, we would say the function is even. And that concludes today's video lecture.